lecture.
Thank you, Doctor.
Okay, thank you. First, I would like to I'd like to say that Shukran, we can meet again. Sorry for interrupt your long holiday. Because we only take 2 hours, then you can go back to your whatever you've done earlier. Typically to spend your holiday with your family or perhaps with the loved one. Yeah. Okay. As I mentioned earlier, it is the second topic, the second major topic. Yeah. If you look at very careful in the schedule of the topics, one will be the gearing system that we completed, Alhamdulillah. The second part, we jump to the balancing of rotor balancing engine. This is the fourth chapter. If you look at my books, yeah, this is the fourth chapter on page 161, which called effect of gyroscopic couples. But when I designed the learning schedule, typically we take the chapter 4 to become the second topics in the what do you call it, in the evaluation. Perhaps I can say in test one. So the topic will be in your test one will be the gearing system that we have completed, Alhamdulillah, and this one will be the second topics. So the balance will come after the completion of these topics. Okay. Um, uh, and I did mention about I will on the video, so I need you to put on proper attire, so to ensure that everyone can recognize and now you are recognizing my voice, right? So we can recognize me. So beyond that is basically to enhance the use of thumb rule and also right hand frame rule. It's not for the sake of looking or videoing or perhaps observing people, yeah, to show you in the realistic of using the what do you call it, the thumb rule and also right hand frame rule. Okay, that is the idea why you need to on your video so that you can see my hand, how my hand will be show the proper attire, proper direction of rotation, and also vector. You have two vector direction also, direction of rotation. Yeah. Okay, that is one. The other one is even because this is not the class that should be on. Yeah. So the next session will be tomorrow. Yeah. Which is the official class. I also be what do you call it? We captured what we learned today. So those who are coming today, so you have a benefit to what do you call it, to study more, because I'm going to recap thing that we have discussed today. Okay. I don't want them to left out. This is for the sake that when you know that part of the note had been given, so the next topic will be the next meeting will be very easy for you. Okay, so this is the one. So before we do further, yeah, I would like to what do you call it, yeah, to check on the title itself. You look at the title. The title say, if you look, you can see my cursor here, the pointer. So this one is the effects of gyroscopic couple. So we have three magic or perhaps three words, keywords. One will be the effects, the other one is gyroscopic, the one is couple. The gyroscopic itself is a device. Yeah, it is a device, a mechanical device. It used to show you the rotation, the direction without independently. Okay, used in vehicle, for example, used in ship, for example, for stabilizing the condition. The other one is the effect. This one is more toward in the kinematics effect and also couple. First we go to effect. So effect means that you are basically applying the Newton law, where the Newton's law say that action equal to reaction. So the effect is basically the reaction of the gyroscopic couple. Okay, so now you know what is the what is the what you call content of the topics. The other one is the couple. You know, when that couple you have two forces. When you have two forces, it could be a moment. Couple and moment, two different things. Even though the equation is very not same, very same. Equation of couple and moment is the same. But if you look at in vector direction, it will be it is very different. Couple, when you have two forces acting what opposite direction, and it will be what doing the rotational, isn't it? So either clockwise or counterclockwise. That is couple. For the moment, it will not. Moment can be what? Two forces acting same direction. This one, two forces acting different direction will make you one circle that is couple. Okay, so now you know the effect. So we are going to apply the technical law, action equal to reaction. Then you are going to look for the device, the scoping, and then finally we're going to look for couple. So in the content of this topic, you are looking for tools. One will be the, what we call it, the motion itself. The other one will be kinetics. Sorry, kinematics. Or perhaps I can say that the first part will be kinematic, as what we did in every cyclic gear. The second part will be the kinetic. So the kinematic is basically involves of all the motion. You will have the direction of rotation, you have the direction of vector, something like that. Yeah. And when we do the kinematic, of course, we are going to calculate all forces acting on the gyroscopic on the device. The device will be supporting by, for example, yeah, bearing. They're going to look for what are the forces on the bearing. Then we finalize whether the bearing, which bearing will fail first due to the effect of the rubber. So these are interesting topics. Yeah. So we are going to look for a couple of things here. One will be the rotor itself. The other one is the aircraft. You will have naval ship. And last but not least, we're going to look for land vehicles. In here, for the land vehicle, we're not going to talk about, for example, we're not going to talk about motorcycle because motorcycle have two wheels. So the gyroscopic effect will be based on the rider itself. For the vehicle, it will totally based on the body or based on the vehicle itself. For the vehicle, let's say trolley, anything that the tire or the wheel be sit on the space surface. A trishaw, trolley, cars, lorry, for example. So things like a vehicle will not be part of your topics, even though it is more interesting if you go for the motorcycle, for example, because they just got to keep changing depending on the rider. Okay. So this is the actual thing. This one, yeah, is the actual gyroscope, as I mentioned earlier. The device. So this is the device. Look at the device, huh? Yeah, the device. If I can change this slide here. Not, I'm not sorry. What I mean is, if I can share the share this. Sorry, yeah, what? This one. I need to write something on the screen. Look at here very careful, class. So this is what we call as the device, as I mentioned earlier, device. Yeah. So yeah, what does this mean? What does this talk about here? Look at here. Gyroscopics. Okay, question. Will the definition of the gyroscope be part of the test question or exam question? No. There will be no, definition of elaboration of the devices, but they will be one. They will be talking about what is the function of gyroscopics, things like that, because we are all engineers. We are not, things like that, define something. So this one, for example, yeah. So if I can draw here, this one, gyroscopic is device measuring and also maintaining the orientation based on the principle of conservation of angular momentum that you learn in dynamics. So the device is spinning wheel. Look at that. This is the combination of the device. The spinning wheel. So where are the spinning wheel? So this is the spinning wheel. This one is the spinning wheel. Okay. This or this perhaps, if it's not wheel, it will be rotor, for example, whose axle is free to any of the rotation. Look at here. It will be, well, this one is a shaft, isn't it? So this wheel or this rotor, for example, or this for example, yeah, will be held by this one. What we have, this one is we might call this one as bearing, for example, or bracket, for example, or pin, for example, most likely like the bearing. So you will be spinning it own axis, but at the same time, this one you have another shaft, and this shaft also rotates. So you have one what do you call it, degree of freedom, 2 degree of freedom. Of course, this one can rotate clockwise, can also rotating counterclockwise. So you have 2 degree of direction. It's the same thing like here. You have can rotate clockwise, you have counterclockwise. It is not up to that, yeah. But if you look at the base itself, it's on the base, isn't it? So it will the base will be holding this and also the shaft. So with the bracket, this is the bracket, and it will be fixed here. And this belt can tilt that way, clockwise or counterclockwise. So if you found this, if you count the motion, you have 1, 2, 3, 4, 5, 6 degree of freedom. Typically 3 degree freedom. When you'll be rotating clockwise and counterclockwise, it be becoming 6 degree freedom. So this is the beauty thing of gyroscopics. So our aims now is to define what will be the effect of the shaft here, for example, or the bracket here, if the disc rotating with certain speeds. Okay, if you don't not understand, you hold on a bit. I'll be showing you a very simple, analogy later on. Yeah. So this is the thing that if your question asks you, what do you understand by gyroscope? Gyroscope is the thing. There must be combination of three component or three body. The disc, the thing that holding the disc, we call it the shaft or rotor, and the thing that holding these two guys, shaft and also rotor, will be the bracket, for example, and the bracket will be the base and can be tilted clockwise and counterclockwise. Okay, this is the use. You can look at the example of where this gyroscopic being used. Yeah, typically on car, for example, propeller, for example, to look at what the ability of the system. Yeah? Okay, let me go back to share with you with this one. This one's more challenging because you have the, what do you call it? You have this animation. Yeah.
Tolak.
Okay. When I simplify the whole thing, this one to become individual component. You have this one rotor, as I mentioned earlier. Sorry, I can't do anything. I can't write anything. Sorry, forgot. Yeah. Okay, look at here. This one first. You have rotor. If you can observe my pointer rotor, then the rotor will be held by the inner wing, and of course we have bearing here, and the inner wing will be also held by the outer wing. So you have three components now. Then will be fitted on the base. This is the base. This one is the simplification of what you have here, so that you can understand. So everyone be rotating, revolving, moving, and its own axis. Okay, without hit the other part of the body. For example, this one. I think everyone, if you are a kampung boy, yeah, I myself a kampung boy, yeah. So if you're a kampung boy, you used to play a gasing. You know gasing is? The gasing, you have a wooden one, also plastic one. The wooden one, you have the wooden one, like the oblong size. Then you have a pin, isn't it? Or you have a nail, for example. Then you have a very long, quite long road. Then you wind up the road on the gasing itself. Then you throw the gasing, isn't it? So the gasing will be stand still, but rotating vertically. Then couple of time or couple of minutes, then it will be wobble because the speed becomes slower and slower. So you will be talking about what will be the maximum speed in such way to maintain the gasing will be in vertical plane. Then you are going to look for this one pin. This one the pin, for example, what are the force? You know what the force on the pin will exert on the surface, isn't it? So if the force be very big, yeah, you find that the gasing will be dying or stop very much earlier compared to there is no friction, isn't it? So that is one. So then the last one, what will be the speed that to change from the vertical plane to become wobbling? So what we call the acceleration. Okay, so these are the things you're going to look at one. So these are the combination of tools that I mentioned earlier. Okay, so before we go to this one, I would like to share with you a video. So if you don't get this video, I'm going to stop the sharing first. Okay, class, I'm going to share you with you the video. So the video will be this one. Huh? So I don't know whether I can share the video or not at the moment. Yeah. I don't know whether you get the video or not. You get the video or not, class? Let me share with you first. Yeah, I'm not. Let me share with you first. I'm going to share the video now. Share the video. Share the video. Why you this one? You get the video? You get the video, class?
Yes, doctor. Yes, doctor.
Look at this one. So this is the thing that we are going to learn. A couple of ways. Ahead. So look at it. If I can stop this one, I can stop this one. I will stop it. I can stop it. I will pause it a bit. So I need you to understand this one. Okay. I will pause it. Okay, look at them. You have this one. This is what we call the. Typically, you don't have the added mass. So you have a rotor, you have the inner wing, you have the outer wing. It will basically the inner wing will be horizontal, isn't it? Correct. But when you put the added mass, it's so obvious that this one will tilt down. Correct. This one will flop down. Correct. Because due to the added mass, it is no longer balanced. But in here, you as an engineer, you are going to design the speed of the rotor in such a way that this inner wing will be at the horizontal, even though you put something on the inner wing. So that is the idea. So that you're going to look ahead. Yeah, we're going to look for what is the possible speed, for example, to ensure that this inner wing will be maintained at horizontal plane, even though you have a unbalanced mass, for example. So if I can, start over again, look at here. So that is your work now to define what be the speed of the rotor. Beyond that, it is not only that for the kinematic. We are going to look for kinetic, for example. So what are the kinetic? If I can pause here a bit now, I can pause it. Look at here. It will be what? It will be supported by bearing here, and also here, and also at the blob here, isn't it? The added mass. So you are going to look for what are the force on each bearing, for example, due to the motion. So this is the kinematics. And when we have force, we are going to look for the possibility of gyroscopic couples. Then we are going to learn more on that. Yeah, what will be the type of force? You have type of force, for example, compression. You also have one tension. You also have the shear force, so on and so forth. What you learn in strength of materials. Yeah. Then we decided, or perhaps we can estimated that which bearing will fail first, after another, or what be the possible speed the system will be running, functionally. Okay, so that is one. I'm going to stop this one. I'm going to stop this one. I'm going to show you another one which is very, very, even very what they call it, very challenging or interesting. Yeah. Let me, you hold on. I'm going to share with you. 1 minute. 1 minute. 1 minute. Okay, sharing. I'm going to share this one. Okay, tell me, do you hear the sound or no? Yes or no? Can you hear the sound?
No, no, doctor.
No. From the video, no.
No. Really no sound.
Let me out. And you get the video, correct?
Yes, doctor.
Okay, only not the sound. Yeah, okay. Let me check where do I go wrong. Yeah, let me check. I'm going to stop sharing again. I'm going to share. I don't know. Not very familiar with. Let me check ultimate sharing. I don't know where is the sharing part. I'm already on everything here. Ideas. 1 minute. 1 minute, guys. Sharing. Exactly here. I got sharing video. Now there's not sharing video here. So where are you sharing video? Sharing video. Sharing optimize sharing motion and video. Yeah, this one motion and video. So I'm going to share motion and video here. I'm going to share video. Share motion and video. Okay, tell me now, what do you get? You get the
wheel. It's got a string, and it's
you get the sound?
Yes, doctor. Yes, doctor.
Okay, I'm going to start all over again. Yeah, so listen up very careful because this is the thing that we're going to study typically. Okay, let me explain a bit before the video start. Yeah, you have a string here. This is a string. If you can see my cursor, I want my cursor. This is a string, and you have the bicycle wheel here. Okay, if the string will be if the bicycle will be in stationary, so you found that it will flop. It will be at horizontal, for example. When you give some motion on the bicycle scheme, it will turn another phenomena. So let now start the video. Yeah, okay, listen up very careful.
Two. Here we have your basic bicycle wheel. It's got a string and it's tied to one side of the axle. If you put the wheel up and let go of it, it flops over like you'd expect so that it hangs from the string. If you turn it into a gyroscope, though, by spinning the wheel, it doesn't flop over anymore. Instead, what it does is it turns or it precesses about that string. Read the article for an explanation of.
Okay, class, look at here. First, the bicycle wheel will be at horizontal. Then you give a speed, right? That guy give a speed of the bicycle. So the bicycle now will be at vertical. And you have two speed here. Look at here. One will be the speed of the bicycle. The other one you found that the bicycle also revolves due to the string, right? So you have two speed. One speed, what we call spinning velocity of the bicycle wheel. The other one is the whole system, the bicycle and also the string will be also rotating. So what we call as precession. So you have two speed. Remember that. One be the spinning due to the bicycle. The other one the precession when the bicycle also turning. One will be turning on horizontal plane, the other one turning on vertical plane. So that is the kinematics. On kinetic, we're going to look for what is the tension in core to ensure that even the bicycle will be rotating or turning with certain speed, it will not, it will not break. So we are going to look for that, yeah. So that is very interesting topics. Yeah. Okay, any question before I close the video? Any question? Or you want me to see one more time before I close the video? Hello?
Yes, doctor. One more time.
Okay, thank you. I'm going to roll it back.
Two. Here we have your basic bicycle wheel. It's got a string and it's tied to one side of the axle. If you put the wheel up and let go of it, it flops over like you'd expect so that it hangs from the string. If you turn it into a gyroscope, though, by spinning the wheel, it doesn't flop over anymore. Instead, what it does is it turns or it precesses about that string. Read the article for an explanation of why. Two. Here we have your basic.
Okay, so that's about it. So I'm going to stop sharing on that video. I'm going to close so many file here. So I'm going to close another file. Okay, interesting, isn't it? Okay, now let's go back to our notes here. Show notes, yeah. Okay, these are our notes again. This one I already explained, yeah. So now we have idea. So what are the things we need to learn? Couple of weeks, yeah. So first is to define what be the speed of the spin of the precession, for example. So two speed now or two velocity. One will be the spinning velocity, the other one will be the precession velocity. So the spinning velocity, if you look books, for example, book written by Simpson, written by Prasad, for example, they are not mentioning about the spinning velocity. They are talking about what they call it the local velocity. Local is the small part, yeah, and the other one which is the precession. They're talking about global velocity. It simply means that the global is the whole such will be revolving or rotating. Okay, if you read book, there will be no spinning. There's no spinning velocity. There's no precession. They are talking about local speed and also global speed. Yeah. Okay, I'm going to show this one now. This one. This is the what you call it the what do you call it? This one is the derivation of equation. So you know that if I can go back to, I need to show this one animation because when I show you in animation, you have an idea. So what you've been what you've been learned in dynamics. So look at here. Okay, where are you? This one. Sorry, I keep changing slide. I want just to ensure that you really understand the topics. Yeah. So look at here. Okay, what do you understand this one on my right? You learn this one, right? The velocity and also the acceleration, correct? So the velocity, you will have two rule. One rule, but talking about the right hand Fleming rule. If I can show you my hand here, I'm going to on my video. Okay, this one, yeah. This one is thumb rule. Everybody, can you see me? This one thumb rule. Hello?
Yes, doctor.
You can follow this one thumb rule, thumb rule, thumb rule. Thumb rule can also pointing this one, pointing to me, or pointing to you. So this is thumb rule, yeah. So the thumb rule will be, you have this one, the direction of the vector. Okay, this one will be direction of rotation. Okay, direction of rotation, that's a vector. Direction of rotation, that's a vector. If you're pointing to me, for example, direction of rotation, counterclockwise direction of vector. If it's pointing to you, for example, you will have direction of rotation clockwise, this one direction of vector. Okay, the other one is right hand flaming rule. Look at here, this one is right hand flaming rule. Okay, the right hand flaming rule will be comprising of the thumb itself, pointer, and the middle finger. Okay, the thumb is the precession. Remember the wheel just now, the bicycle wheel, the precession. This one will be what called as the spin. This one will be couple. The middle finger will couples. Yeah. So you have the precession, spin, precession, couples. You need to know this one. So you have only two rule to to familiarize so that you can easily use in the solution. Yeah. Okay, now look at here now. Look at here. So you look at this one. You found that you'll be rotating the other direction with pointing upward, isn't it? Pointing upward, rotating the other one with pointing downward. Oh, perhaps I can say that if you view from bottom, for example, you were rotating what? Rotating clockwise. This one rotating counterclockwise. Okay, so this is the thumb rule. Okay. Okay, now look at here. The thumb rule here is basically comprising of here, yeah. The thumb rule basically comprising of, you study this one in dynamics. This one we H equal to IW is basically I dot W is the dot product and also cross product. You learn this one in vector, right? Dot product and also cross product. So what is the dot product? The dot product is basically this one here. The dot product is basically the two parameter will be in the same plane. When you have the cross product, obviously will not be in the same plane. So look at H. H is the notation for what do you call it, for the angular momentum. Okay, H equal to I cross W. And this one is W, but it's not W, it's omega. I want to say W because most of you see this one W. It is W in alphabetical, in term is the omega. Okay, then this one, the G equal to mv, is basically the linear momentum. This one you very familiar with this one. Okay, when we are talking about angular momentum, look at here. Look at the I in W. So you put it your I, you put it your hand on the shaft. You hold the shaft. It's better for you if you have the pen. Yeah, you hold the pen. Then easy for you. Then you know that the pen will be pointing that way, or the pencil will be pointing that way. So the pointer or the pen will be pointing at what we call the direction of vector. This one will be direction of rotation. So if you pull the other way, isn't it? They will be pointing upward. You pull the other way, pointing downward. So that is the thumb rule for angular momentum. Yeah. Okay, so this is the equation now. You have this one. This is how to generate the equation. Okay, I'm going to stop sharing this one. I'm going to share with you the PDF file so that I can write something on it. Yeah, so that I can write something on it. This one. Okay, this one done. You have this one. You can turn to page 163 or 162 if I'm not mistaken. Yeah. Okay, look at very careful. This one, you have a rotor. This is the rotor, or this, it doesn't matter, yeah. This, so this one be rotating with omega. This omega is what? Spin velocity. Just now, remember, spin velocity is the spin velocity. Okay, so and at the same time, if you remember, for the bicycle wheel just now, at the same time the string also rotating. This one, this is also omega. This one also omega. This one is the small capital for W. This one big capital W. If you look at the sign, sorry, if you use the font symbol font, but we call this one omega. This one we call omega, but it's very difficult to differentiate. We call this one as precession. Precession velocity. If you read excuse me, if you read my book, yeah, in Malay, my Malay books, this one we call liuk, Liuk, liuk. I got also, you know, American information in Malays, can get in koperasi or corporate, our koperasi, yeah. I don't know how much is it, we call it halaju liuk. This one is halaju spin, is halaju spinning, putaran, yeah. Okay, now this is the precession velocity, this one be the spinning velocity. So when you have do these two, then we're going to apply this one, these two, yeah, omega, and also let's say spin and also precession is done on thumb rule. And when you are going to decide that will be the couple m, yeah, even though m is also known as moment, we put m as couple, then you use right hand Fleming rule. Okay, I'm going to show you what is the right hand Fleming rule. Look at here, as I mentioned just now, isn't it? This one is spin, this one be the precession. You can follow, yeah, you can open up your hand and follow this one, so you have spin, just precession, this one is couple. So you put on the screen, you put on the screen. So you, if you put on the screen, you found that this one will spin the pointing that way, correct? Sorry, this one, yeah, be pointing that way, isn't it? Am I correct or not? Be pointing that way. This one be precession pointing that way. So that will be the couple, correct? So this is the couple. We call this one as couple, huh? If you do another time, yeah. So this is the couple. This one couple. So you have the couple. Remember what you get? Yeah, the actual thing on the right hand Fleming rule. You get the active couple. The active. Remember the active couple. But from the very beginning, I did mention, but our aims now is to define what the effects. So this is not our concern, and this is not our interest. Our interest is to look at the what the effect. So the reaction. Effect is the reaction. Okay, so I noted as m prime, this one m. Okay, that is how to use the right hand Fleming rule and also thumb rule. You have with you here, this one is the definition or perhaps the derivation of the equation. This one is basically not, you know, it's not very new to you. If I can share with you, if I can share, I go back to the, you have this one here. If I can share with you, I try to use this one. We have a blank screen, isn't it? You have a blank screen with you. Start with G is equal to mv, remember, dot v, and you know well that the v equal to, sorry, v equal to omega cross r. So you put it here, you'll be getting G is equal to m. This one will be the omega cross r, correct? Isn't it? So you have the m, cross arm. So this is what you have learned in dynamics. This one, yeah. Oh, sorry, this one we have learned this one. But when you use this, when you use this one, h, for example, what does h is I omega, isn't it? So you put this one here, yeah. If you forget this one, I omega. Okay, now I omega. So if the I now, let I now is equal to mr square and r is equal to radius of gyration, then you put it here. This is the mr square, isn't it? Omega. How this one can change this one? How is it? Anyone? How this one you want to put this one? How is it? Remember, h equal to g by what? G by what you learn in your dynamics? By g, isn't it? So equal to, you have m omega square, omega, this one r multiplied by r. So if you simplify this one, it becoming m r square omega, which will be equal to I omega dot product. So it'll start with what? The combination of linear momentum and also angular momentum. Okay, go back here. So you have this one. Then what you learn in dynamics is basically what you learn in dynamics. Yeah, you learn good in dynamics. Yeah, dynamics say that H equal to I dot omega, correct? But this one is at that particular instant. At that particular instant. What does it mean? You are studying a body at that particular instant without changing of time. But when time change, you will have dh by dt. This one will not change. The moment, mass moment of inertia will not change in over a period of time. Even the over a different axis, it will not change. I is I. Omega now will be changed the omega by dt. And you know well this one can also be written by, that is what you have. This one. Okay, how it come M? You learn in dynamics again, M is equal to I dot alpha plus MA D, right? A general equation for rigid body motion, remember? And you know that when rotation on a fixed point, a special topic, you have M equal to I alpha, correct? This one is a rho 2 is rotating on a fixed point, so you can use this one also as M. You have this one equation. I think last two semester, you need to have this one on your own, yeah, to define what the equation. You will have this one. Okay, this one is on x-axis, isn't it? On x-axis. Then on y-axis, look at on y-axis. This one on x-axis. Look at what happened on y-axis, because these two axes will be what occurring simultaneously at the same time. So you found that the dh, this one will be the delta psi, is the different when this one be tilting. So this one is obviously here. Over a period of time will change this one, correct? So look at here. This is the equation. Over a period of time, h multiplied by d delta by this one, you have this one. Initially, you have only this one, isn't it? Then with this over a period of time, then you will have this one due to the equation. Then you take this one and put it here, you becoming the last equation what we have here. Okay, people ask me, sir, equation most book use this one. This one is precession cos omega. Other book use this one. My book I use this one. I dot omega cos. Okay, let me explain before you confuse. Yeah, this two equation is basically correct. It is basically correct due to the what do you call it? Due to the analogy and also due to the magnitude and also vector and direction. The only difference now, some people or some scholar use as this one because this concern about this one. Why? Look at, you go back here. If I can clear this thing, look at the plane for this rotation and also for the spin and also what do you call it just now? Precession. Where is the plane? The plane is this one, yeah. This one. Look at the end. This one. So this is the plane, isn't it? Correct? Yes or no? Yes or no? Yes or no? Yes or no? No one answer. You hear me or no?
Yes, doctor.
Correct or not? This plane, isn't it? So it means that this one will be what? This one will be this one cross with this one, correct? And it pointing to you. Am I correct or not? It will be pointing the other direction. Because why? Because here cross omega. Am I correct or not? It will be pointing inward the screen. Am I correct or not? If you have the omega cross the it's not astaghfirullahaladzim. Because both are omega, yeah. If you found that this spin cross precession, what do you have? You have the other. Let me put another color. You have this direction, correct? So it will now come out from your skin. Am I correct or not? Yes or no? Yes or no? Use thumb rule. Okay, let me on my video here. Okay, the first one. Look at here. This one. that be pointing to you, am I correct? Pointing to the, sorry, pointing inward screen, because you have that one, correct or not? And this one will be pointing to me, pointing to me, pointing to me, because be rotating that way, because omega crossed by, spin crossed by the precession. So we go back to the equation just now. So it can also be this one, or it can also be this one, depending on where you are, correct or not? This one, depending on where you are. Huh? But the most important thing is here. This is not. This one will not change. Look at the I omega. Go back to the equation I omega. Look at the I. This one is I and omega. Why I? Because I remember I equal to half mr square. This is the I. It's always what? Dot product. It will not I n precession. It's always I n spin. So that is why you will have two equations. Even the equation, both equations are correct, yeah. You found that some people might use this one, some people might use this one. Both are correct. How to explain? As I mentioned earlier, this I and precession very rare, but this I and omega all almost. But talking about magnitude, it is the same. Talking about magnitude, it is the same. I'm talking about vectors now. So if you read book, for example, you found that some equation will be not in this term. It becoming this one is the precession, this one's omega. But be ensure that these equations are basically correct. And my equation, the equation that I use in the book is also correct. That is to explain some of you might be thinking by why another books written in such manner. Yeah. Okay, I'm going to move to another one. This one already discussed earlier. The use of thumb rule and also Wright and Fleming rule. Okay, you hold something, you're pointing that way, you hold something pointing to it, so on and so forth. This one is the what do you call it, the definition of the thumb for the spin, or for the precession, this one for the spin, this one for the moment, and the actual thing is always active. So if the question asking about, for example, yeah, a shaft carrying by the bearing, so this one be on shaft, on shaft. So on bearing will be the other direction. This one be M prime, which is reaction or reactive in bearing. If it's not bearing, it could be pin, for example. It could be bracket, for example. It could be also couple, for example, so on and so forth. Universal couples, yeah. Okay, we move on. This one is again is the use of omega, and also, or perhaps I might say that it's the use of the spinning and also precession. This is the spin velocity. Spin velocity. This one is the precession. Well, this one the spin velocity only rho 2. This one the whole structure. Okay, now I'm going to ask you something. If you can answer this one, then I can proceed. So if you're talking about, for example, yeah, if you're talking about, for example, a motor car, a car. So which will be this spinning velocity? Which should be the precession velocity? A car, for example. Anyone? Could anyone answer? Hello? Anyone?
Maybe
Speak up, please. Yes, Dan. Dan, speak up, Dan.
the car engine is the motor engine is omega, and revolve around the circle is the thing the precision velocity.
Okay, if you're talking about car, for example, yeah, what makes the car move is the engine, right? So the engine running with certain speed, and of course the engine will be attached to the axle gear. Then the gear will be axle, and then the axle will be attached to wheel. So the wheel now is basically the spin velocity, isn't it? Why? Because the wheel make the car move from one station to another station. While driving, you turn to left, you turn to right, for example, or you hit a hump, for example, or you hit a pothole, for example. So you are basically the precession. So the precession will be the velocity of the entire body. The spin will be this the thing that will be making or make the system move. Okay, so that is, if you're talking about aeroplane, for example, like aircraft, you have a propeller, you also have a body of the aircraft, right? So the propeller will be acting as a spin velocity. Of course, it's not the propeller, yeah, it's basically the engine. The engine, attached to the gear attached to the shaft, then it go to the propeller. The propeller now will be running with a certain speed, for example. Then the aircraft will be turned to left, turned to right, diving and climbing, so on and so forth. So the motion of diving, climbing, turn to right and turn to left is the precession, while the propeller moving or rotating with the spin velocity. So the velocity, the spin velocity, basically that making the aeroplane flies. So that, bear in mind on that. Yeah. The other thing is, you know well that when we are talking about spinning velocity and precession velocity, if you're talking about the magnitudes, yeah, numerical, you are looking about the spin velocity is very huge, very big numbers, and the spinning velocity, sorry, the precession velocity will have a very small number. For example, yeah, for example, a car. Listen up very careful. Or for example, aeroplane. For example, aeroplane fly with a speed of 240 kilometer per hour. That will be the precession velocity. And at that particular instant, the engine running with the speed of 12,000 RPM. So that is the spinning velocity. So that is why you found that in vehicle there are two meters. One is tachometer, the other one is speedometer. The tachometer will tell you about the engine. The speedometer will tell you about the speed of the vehicle or speed of the airplane or even the speed of a ship later on. Okay. So now let's focus on the spinning velocity. So if you this one, you put your hand here. You put your hand here. Then it will be pointing the other way. Correct? Use your hand now, class. Follow the figure. So you have, yeah, the most important thing is the vector direction or direction vector. The other one is rotation, direction of rotation. The direction vector is due to thumb. The direction of rotation is due to your finger. Then your flow or your finger. Yeah. Your The other one is pointing inward of your screen, for example. So inward of your screen. So you have this one. This is your thumb, direction of vector, direction of rotation. And pointing upward easy to see. This one you have the direction of what? Vector, direction of rotation. Okay, look at here. Only this one, only what? This. Only this. We are focusing only this. Now is this plus shaft. The whole structure carrying this. Two different things, right? Even though we call also omega, but we call this one as precession velocity. So it simply means that the shaft rotate, this one also rotate. But in this one, you found that the shaft rotating with the same direction of this. So it'll be pointing that way. So both are pointing in the same manner. Direction of a vector, this one direction of rotation. But in the other way here, you found that this one be rotating here, isn't it? But now at the same time, the whole structure will be rotating that way. So finally, I will want to conclude that the thumb rule, look at it, the thumb rule can be used for spin velocity, can also be used for precession velocity, can also be used for moment, couple, moment or couple. The thumb rule. So that is the most important thing is thumb rule to point you the three parameter: spinning velocity, precession velocity, and also couples. Okay. This one. Okay. Put your finger here. Put your finger on screen, class. Put your finger on screen. You found that okay. First, this one. This one is number one. Number one. Spin. Spin that way inward of your inward of your screen. I'll always mistaken see that whiteboard. Yeah, it is on the screen, near your screen. At the same time, the whole structure will be rotating, pointing upward. So you will have this one number two, this one number one, and number two on what? Thumb rule. TR is thumb rule. Then to define this one is by using right hand Fleming rule. How is it? Put your finger on the screen. Put your finger on screen now. Spin. This is spin. Precession. This one be couple. Couple be pointing outward of your screen. Of course, if you see my video, yeah, my video pointing the other way around. Okay, so it be pointing inward. This one pointing upward. This one pointing to you. Correct or not? So then you know that this one is this one is the pointer, this one be thumb, this one be the middle finger. And this is not our interest because this one is due to active. Our interest is one, the reactive. So you have another couple, M prime. We call the reactive couple, or sometimes we call it reaction couple, or sometimes we call it effect. Got here. I really hope that you understand this one, my introduction. Okay. Any question before we proceed? Any question?
Doctor.
Clear now. Okay, this one, another one. Yeah, this one just the repetition of this one. Yeah, I put it another slide so that you can, understand this is how the use of the thumb rule on each. So the thumb rule, remember, thumb rule can use every parameter. Is this one also, and also this one, thumb rule. And again, this is the action. This is our interest in the reaction. So the problem now, where are we going to use this one? We're going to use this one, for example, on bearing. We're going to use this one on what else? Brackets. What else? Pin, for example, so on and so forth. Anything that hold the shaft. Anything that hold the shaft. How is it? We're going to later on, yeah? This one, the active one, will be basically on shaft. Why? Because this one, the active, the actual thing occurring on the shaft at that particular instant while you are doing analysis. Okay, I'm going to proceed. This one, another example. Look at it very careful. You have this one motor. This one is motor. The motor is sitting well on this turntable. This one is turntable. And the turntable rotating that way as given. The motor is rotating that way as given. And this motor is basically what? Hold by a bracket. This one AB is bracket. Of course, inside the bracket, yeah, bracket is basically the bearing housings, or the housing of the bearing. Yeah, the bearing housing. So inside the bearing housing, you have the inside the bracket you have the bearing housing. So it could be the bracket. It also could be a bearing. It's the same. It's the reaction of the system. Huh? So now, if you start with this one, you put your hand here. So if you look at from one point, for example, this one is rotating what? Rotating that way. Is it rotating that way? When you look at here, it's rotating what? Clockwise. So you will have this one. If I can put here a bit bigger spin. All right. Question. How do you know you are looking or viewing from this one? The question will tell you to do so. If the question doesn't tell you anything about it, any point to view, for example, you have to make your own assumption. Okay, look for a view from B, view from A, for example. This one is view from B. Okay, so how do you know? The question will tell you to do so. If it is not, you have to make your own assumption. If you're looking from here, for example, yeah, you are looking from here, it's mean that this one will be rotating counterclockwise, isn't it? It is pointing this one. So it'll be pointing the other way, correct? So it depends on where you are viewing, yeah? And the other part is this one. So from bottom, for example, it'll be rotating that way, also clockwise, Look at here, also clockwise, pointing this one, clockwise. So you have the precession will be here. The next one is to define or perhaps to decide where be the couple. Put your finger on the line of spin, your precession, the next one be your couples. The couple will be this one, M, active, pointing to you, outward of your screens. And it is not our interest. Our interest is to define this one. And of course, yeah, excuse me. Of course, the equation used is exactly the same. Still I dot omega cross precession. This one also for m prime. Doesn't matter. We are talking about m or you're talking about m prime. The only difference is the direction. Same direction, sorry, same magnitude, different direction, because we are applying one. Third Newton law, action is equal to reaction. Okay, I'm going to move another one. Example. Is that clear? Yes or no? Anyone like to ask before we proceed?
Doctor,
Yes.
can you come again? What is the reaction useful? The reactive couple.
Reactive couple. Okay. Before that, let me clear this one. Yeah. Who's on the line just now? Is it Ko?
Lin.
Lin. Okay, Lin. Okay, I'm going to clean up this one first. What is the reaction? Okay. Okay. Now, thank you for the creation. So look at here. You know this one has been asked in question to look at or perhaps to view from B. You are viewing from B, you found that to be rotating what? From B, this one rotating clockwise. So this one is rotating clockwise. Then you put on, this is what we call gyroscopic vector diagram. Gyroscopic vector diagram, you have this one, correct? Then it also mentioned that the turntable, this one turntable, can revolve. You have two things. In English, you have so many vocab, yeah? So you have rotation. The other one is revolve, revolution. Same thing basically. But in gyroscopic topic, this one is for spin. This one is for precession. Okay, but you can also rotate, doesn't matter. As long as, if you read book, what is different between rotation and revolution, it is same. So if revolve, pointing upward. If you look from bottom, yeah, it'll be rotating clockwise again, isn't it? Yes or no? Clockwise, isn't it? Clockwise or not? This one also clockwise. Am I correct or not? This one also clockwise. Put it here, clockwise. This one also clockwise. Am I correct or not? Yes or no?
Yes,
Also
Doctor.
rotating clockwise. Yes or no, class?
Yes, Doctor.
Okay, yes. Okay, now, so your aims now is to define couple. So put your finger now. Put your finger. This one be spinning. This one the precession. Don't bring out your middle finger. So your middle finger pointing to you. Your middle finger will be pointing to you. That will be the active. So this one, active, pointing to you. So now it is pointing to you. So it'll be rotating that way, pointing to you. Is it? Pointing to you. So it'll be rotating what? If you view from that end, will be rotating counterclockwise. Am I correct or not? Yes or no?
Yes,
Do
Doctor.
this one. Yes or no? Yes or no, class?
Yes, doctor.
Okay, now this is active, right? So the active one is always on shaft. Why? It's the actual thing occurring on the system while doing analysis. On shaft. Why? The motor is carried by shaft. This is the motor, right? So this is shaft. So the motor is carried by shaft. But remember, the shaft is now carrying or supporting by bracket. And inside the bracket, you will have this bearing, because the bracket is the bearing housings. So this is the bracket. B-R-A-C-K-E-T bracket. And inside the bracket, you have bearing. So if this one the active, this one will be becoming reactive, isn't it? Why? Because we are applying third Newton law, saying that active equal to reactive, same magnitude, different in direction, opposite in direction. So you pointing the other direction and the same axis, we call it as M reactive, and put it there bearing or perhaps brackets. Am I answering your question or not? Lee.
Yes, doctor. Understand now.
Okay. So then what? Then the next one we are going to use this one to apply in our system. So later on you have to you have to stay tuned in with me. Yeah. So I'm going to explain to you how to find the force on bearing later on. Okay. This one is the example. The example we are going to look for example. Yeah. This one is the start with the easiest one. It's not the easiest one. It's basically the basic one. Yeah. The rotor and shaft. This one, the aeroplane is which more challenging. The helicopter, in fact, the most challenging because you have two propeller. Like Nuri, for example, right? Nuri, even though Malaysia now abandoned Nuri, but as you look at Nuri itself, you have two major two major propeller at the front, and the other one is at the back. You have also a propeller, two propeller. If you look at the very typical helicopter, for example, you have a major propeller on top. At the bottom, you have also propeller. The bottom one will be also, so it's not the bottom one. The rear one will be propeller rotating in the horizontal. The other one rotating in vertical. So the horizontal is basically to maneuvering the helicopter, while the top one, the main propeller is to lift the propeller, to lift and also to fly the propeller. And then you look at the naval ship, boats and vessels, same thing. Yeah, some boat will be running by small propeller, some boat will be running by the huge propeller. And last but not least, of course, we are talking about motor car and trolley. Okay, and this one with this one is two different condition. The reason is why I'll be explaining to you when we when we meet the vehicle topics. Very interesting because you are driving every day there and here and there. Okay. Okay, I'm going to before that, of course, in here, yeah, our aim is what is our aim is basically as engineer. We are going to look for example, yeah, an aeroplane fly with certain velocity, for example, then it take turn left turn or right turn or diving or climbing. So we are going to look for what would be the possibility of the bearing or bolt and nut to hold the engine in such a way while turn to left, turn to right, diving, climbing, the bolt and nut will hold steadily, will not fail the system. So that is the idea. Or for example, vehicle, yeah, like while driving, suddenly you take a corner, a very sharp corner. So we're going to study about which wheel. We have four wheel, right? Which will have tendency to leave the ground. When you leave the ground, then you will have the off-road or turn turtle, isn't it? Your car will be turn turtle, isn't it? So that is our study now to ensure that what will be the possibility of speed to ensure that the four wheel will be stick on the ground. That is why you found that when you're driving a car, yeah, when you reach a roundabout or any sharp corner, they will provide you a speed limit, saying that not exceeded at that limit. If you exceed the speed limit, you will experience off-road, for example. If you don't believe me, when you meet a signboard, say that okay, slow down 80 kilometer per hour when approaching roundabout, you speed up at 90 kilometer per hour, then you tell me it is correct or not. But if you if you your car have a off-road, then don't believe me, because I'm telling you the exactly what the engineer been done on doing or calculating that thing that on the roads. Of course, beyond that, it also again looking for what are the effect on bearing then, because the vehicle or the tire or the wheel will be supporting by the brake, the wheel. So there is if you're driving, yeah, you make U-turn very a lot of time, U-turn, then suddenly you found that 1 or 2 years you find that you're bearing your front wheel basically run off, or perhaps having problems. So avoid make a U-turn very often. Avoid. Typically a very sharp U-turn. But of course, if you don't have choices, you have to go for U-turn. Okay, now this is another example for shaft and rotor. These are all the things you're going to learn later on. Shaft and rotor. This one you have a propeller. You have the motor run the propeller, and this one at the same time while the motor run the propeller, the whole structure. This one also revolving with the speed of 30 rpm, for example. Same thing like this one, you have propeller here. This one you have pulley. The motor run this boat, and at the same time you have a swing here. It will swinging clockwise, counterclockwise, and at the same time also revolving. So how many motion you have? One motion, two motion, three motion. Isn't it? So what is the aim? To define what be the possibility of which both and nut fails. And here, for example, you have this one. This one is fork. This one is a shaft. This one you have added mass, and this one be tail. Then you have to look for what will be the speed here. In such way, this one will not tilting, and this shaft will be on horizontal plane. This one, as I mentioned earlier, this one another one. We have this rotating that way. At the same time, this one also rotating. So at least we have two motion, one motion, two motion. This one is very challenging. We have three motion. Typically, like a motorboat, for example, speedboat, for example, while while driving, then you what? You hit a wave. Then the front end will what? Will facing or ascending. Will ascending. So what does it mean? So it'll be ascending is the precession. But then at the same time, also you are turn to left, for example. So you have two motion. That is more challenging. So you're going to do that later on. Okay. This one is the aeroplane, but not very much to talk about, because I already talked earlier. This one is the engine. Earlier we have compressor and turbine. So our aim is basically to look at what will be the bearing, force on bearing to hold the compressor and turbine while the aeroplane climbing, diving, and also turn to left and turn to right. It is not on that. It's also what do you call it? Rolling, rolling, yeah. And finally, you have boat here. Boat here, you have a boat when this bow ascending, the bow can also descending. Then this one is ascending, pitching up, descending, pitching down, turn to left, turn to round, turn to right. Then you have a roll a bit clockwise, roll a bit counterclockwise. Okay, that is maybe the thing that we're going to talk about in couple of days or couple of weeks. Vehicle, like I mentioned earlier, you drive. While driving, you hit a pothole. Pothole is basically when rainy day, so many pothole. You have to avoid pothole. Yeah. When you hit, okay, now let imagine, you drive with a certain speed. You don't hold the steering. You let it go the steering. Then one of the wheel run off the pothole. What happened to the steering? Could anyone answer me? Anyone?
The steering wheel rotating.
Yes, the steering will perhaps turn to left or turn to right, isn't it? Then you grip back the steering, correct? Or perhaps you're driving, then you hit a ram, or harm. You hit a ram or harm. One wheel only. So what happened to the steering? The steering has tendency to what? To move to tendency to left or to left. So our aims now is to define what happened to the structure, and also what happened to the bearing of the vehicles. So this is very interesting, because this is our daily life experience. Okay, I'm going to start with a very simple one here, class. Here, I'm going to start with this one. So on page 165, you have this one in your notes. So you have a rotor spinning. This one is rotor. This one is rotor spinning. Remember, you have, look at here, rotor spinning with angular velocity in counterclockwise direction, viewed, they mentioned it, from the direction as shown. So this one, you viewed from top, for example. You can also view it from bottom, doesn't matter, because it doesn't mention about viewing from top or bottom. But that what doesn't mention, you have to follow this one. So supposingly this one also not been given, for example, you have to make your own assumption. Okay, so now they provide you this one. If you view from top, for example, this one from top, it'll be rotating what? Be rotating clockwise or counterclockwise? It'll be rotating class. It'll be rotating counterclockwise. Am I correct or not?
Yes, Dr. Counterclockwise.
So now this one is viewed from here. Okay, here you are here. So this one be rotating that way, isn't it? So if you are here, for example, so the rotor be rotating what, clockwise or counterclockwise? Also counter. Am I correct or not?
Yes, Doctor.
So your aims now is to define M couple. Okay, let's try. Let's define now what is the M couple. So the procedure here, this is the procedure, yeah. Excuse me. The procedure will be this one is due to my experience calculating or solving the problem. You start with M or couple. Even the question doesn't ask you. Start with this one. M equal to I omega this one, and of course I this one can also in two form. It could be half mr square. It can also be mk squared depending on the parameter given. It will provide you radius, for example, you have to use half mr square. It will provide the radius of the gyration, use mk square. And this one is the omega, and this sorry spin. This one is the precession. Okay, you do this one, you get the results. Then construct gyroscopic vector diagram. This one applying what just now? Applying thumb rule, applying right hand Fleming rule. Finally, analysis. Analysis on what? Analysis on, the analysis would be based on two things. On body, oh sorry, on motion. You want to define that whether the car turn to left, turn to right, so on and so forth. And the other one on force. So this on force, you're going to look for two. One be on body, the other on bearing. Okay, body and bearing. Inshallah, if you follow the procedure, you will mastering this topic very easy compared to the others, because there is not many equation. Only this the major equation. The rest of the equation is you have made the equation before. This is the only equation that you are learned today. The rest are equation that you use in static, dynamic, or strength or materials. Okay, I'm going to share this one. Look at here. Okay, I'm going to this one. How am I going to? I got problem with the pull down menu on the system. It is my problem because I'm not very familiar with this WebEx. Okay. First is what just now is the M equal to I dot omega cross precession. Look yourself. I could be from M R square, or can also be I equal to mk square. So depend on R or K given. If this one given or this one given, use each one. Yeah, the omega is equal to 2 pi n by 60. This one is spin velocity. Okay, the precession, as I mentioned earlier, also the same equation. Okay, this one is spin, this one is precession. So this one is the precession velocity. The precession velocity. So typically, in conclusion, you found that the omega is always bigger and bigger compared to precession. This one conclusion, yeah. The reason is why sometimes you might not be calculating this one, but they provide an equation. So you look at the bigger one, be always for this spin, and the precision is smaller compared to the others. So our aims now is what? Our aims now is to define the force on bearing. To define the force on bearing. Remember this one, on bearing is not on shaft. It's not on shaft, yeah, on bearing. So how is it? First do this one, number one. Okay, then finally you will have the result of here in Newton meter. Number two is what? Number two is gyroscopic vector diagram. Construct. This one construct using, as I mentioned earlier, thumb rule. This one is right hand Fleming rule. So now you keep asking which one I would like to start first. Okay, use thumb rule. Start with the omega or spin. Then this one will be. Then this one will be the precession. This one will tell you moment. Okay, this one number one. number 2, number 3. Okay, now start. Okay, you are here. You are here. And this one be rotating counterclockwise. Am I correct? Look at this. Look at this. Look at the notes here. You are here. Your eyes is here. You are sit here. You are sitting there. Then you're pointing. It will be rotating that way. So it'll be pointing to you. Am I correct or not? You're rotating counterclockwise. Am I correct or not? So you will have what? You will have. So okay. One minute. Yeah. So let me explain a bit. The gyroscopic vector diagram can also be displayed by 2D and 3D. Two-dimensional or two-dimensional. So we are going to look to do both. Okay, now 3D, for example. So you have this one, omega. Yes, no. Yes, no. Yes, no, class.
Yes, doctor.
Okay, now at least answer me. Yeah. Otherwise, I thought of I'm talking alone here. So now on top, UI is here. It's also rotating clockwise. Counterclockwise. Sorry, counterclockwise. Counterclockwise, isn't it? It's also rotating counterclockwise. Correct? That will be pointing upward. Correct, not? Rotating counterclockwise, pointing upward. Am I correct or not? Yes or no? So you
Yes,
will have
okay.
here. Yes. Thank you. Okay, then if I can put it here, yeah? Omega, this one is session. And then what? The next thing is here, right hand Fleming rule. You bring out your hand. This one is the precession. This one is spin. This one is couple. So put on the screen. Put on the screen. Put on the screen on your hand. Put on the screen on your hand. So you have this spin, precession. This one will be spin, precession, isn't it? Then couple. So couple be pointing inward of a whiteboard. Am I correct or not? We call this one active. Yes or no? Yes or no?
Yes, doctor.
Okay, now. So this is not our interest. Not our interest. Our interest one to define on bearing as mentioned in the equation. But if the equation mentioning what will be the force on shaft, we are going to use this one. Remember this one on shaft. Why on shaft? Because this rotor is carried by shaft. Okay, so this one, this M prime, we call it reactive. Okay, reactive. So now instead of pointing inward, be pointing to you. And be pointing to you, be rotating counterclockwise, be rotating that way. Am I correct or not? This one is pointing here, it'll be rotating here, it'll be pointing clockwise. Am I correct or not? You have to answer this one because if you don't, if you don't, what do you call it? If you don't understand this one, the next thing will be difficult for you.
Yes, doctor.
Okay. Again, because some of you say that again. Okay, now start with this one spin. I use another color. Start with spin. You are here, so you're rotating what? Rotating that way is counterclockwise, isn't it? So counterclockwise. Oh, I'm sorry. I get yes. Sorry, yes. I get it wrong. Sorry, class. I get it wrong. I get it wrong. I'm sorry. There is what she asked me again not to do it. Okay, now I get it wrong. Thank you. Yeah, thank you. Okay, now I get it wrong. So as you here, you are now looking rotating counterclockwise, it's pointing to you, it's pointing the other way, isn't it? So it's supposed to be pointing here. Then it's correct. Thank you. So you have this one is 3D. I do it again. Now it's correct. And then on top, also rotating counterclockwise, counterclockwise on top. Yeah, counterclockwise. Look at there. This one is counterclockwise. The pointing upward is correct. It's pointing upward. It's pointing upward. Then it's correct. Then your spin. Couple pointing to you. Couple pointing to you. So couple be pointing to you. Zap here. M. This is M active. I'm sorry about that just now, yeah. And active, and typically, as I mentioned earlier, this M active is on shaft, or if not shaft, on body. And the M reactive, it is the same. This M reactive. This one is typically on bearing. Okay, class? Hello?
Yes, doctor.
Okay, doctor.
Okay, yeah? Okay, now this is correct. So let's figure it out. Where will be the rotation? Where will be the direction, yeah? So for M reactive, it come up from your screen. So be rotating what? Rotating counterclockwise from your seat. You have this one. Am I correct? The reactive pointing inward of your screen, be rotating clockwise. Am I correct or not? Clockwise. Yes or no? So this one is number 2 just now. Number 2. It's a gyroscopic vector diagram. So this is 3D. What happens if you want to construct 2D now? So let's construct 2D. Construct 2D. But of course, in the exam or test, you do only one gyroscopic vector diagram, yeah? Either 2D or 3D. So in 2D here, this one is no changes. Am I correct? It's no changes, isn't it? This one also no changes. And then moment is changes. Yeah. So you put it your finger here. This one spin. Look at the spin, precession. This one is the couple pointing to you. Am I correct or not? So as pointing to you, you follow one arrow. Arrow, what do you call it? Yeah, position. So when pointing to you, you will have a dot. Am I correct or not? Yes or no? And this one we call M active. How does it rotate? We rotate this one, rotate that way, which is counterclockwise. And the other one, you have same thing. This one don't change. This also do not change. So the M reactive will be pointing the other way. So if pointing the other way, inward the screen. So as inward the screen for the arrow one, you have this notation. Am I correct or not? Yes or no? This one is M reactive. And as it's pointing inward the screen, so you have this one. Up, clockwise. Clockwise. Is that clear? That's why I have to on the video. I want to see. I want to show you how to use the hand.
Yes,
How to use the hand in terms of right hand framing rule. Is that clear, class?
Clear, doctor.
Okay, now so number 3. What does number 3 say just now? Number 3 is to look at the where number 3 is this one, yeah. Construct. Okay, analysis. We are going to do analysis now. This is the challenging part. Analysis means static or dynamic or perhaps the motion. So let do boats on boats, yeah. This one, the pull down menu do not visible, it should be hide out. This one is not hide. I need to play around with the screen, then you will hide. 1 minute, class. Okay, now when you want to change the slide, the pull down menu is covering your file on top of this one, right? So that's very difficult for me to hide out the pull down menu. And I don't know how to change the pull down menu to be the top one, at the bottom one. It's a very difficult to teach old dog with new tricks, isn't it? Okay, now I'm going to do analysis. Remember this one right here, analysis. For analysis, you focus on a motion. Yeah, on motion. Motion meaning that what happened to the body? What happened to the body? This one force. This one more on structure. Structure. So the force itself you have two. One will be, of course, shaft. One will be bearing. For these two, you are looking for static and dynamic. Okay, of course the equation asks us to look for bearing, so we ignore shaft. So we're going to look for bearing, static, bearing, dynamics. So we are start force first. Okay, now start this one A, this one B. I'm going to start with A first. Okay, A first. Analysis. A first for analysis. Huh? So what you have there? Excuse me. What do you have? This is structure. Okay, remember this one is structure. Structure. Then you have bearing. Okay, on bearing. So we are going to look for this one. Yeah. Structure. Okay. You go back here. So put it there. Look for M prime. Look for M prime. So you go back to your analysis just now. Look at the M prime. So where will be the M prime acting? M prime will be acting what this one, isn't it? Put it there. M. Of course, yeah. In exam, you don't do this one, yeah. So many things. This one, M prime. Okay, so I'm going to put this one counterclockwise. So I put it here. Okay, counterclock. Sorry, it's clockwise. Clockwise. So clockwise. Yes or no? From where? This one from just copy vector diagram. Okay, so now I'm going to look for couple. Couple. How does it? This one is dynamic. Put it the dynamic first. Dynamics. Remember, analysis of static and dynamic. So couple mean that to comply this couple rotating clockwise from your seat, yeah, you must have one force acting here. You must have one force acting here. Astaghfirullahaladzim, put it back here. You must have one more here. Put it as F. If this one will be A and B, for example, put it there, A and B. Okay, so your M earlier is equal to I dot omega cross precession. So your M also known as F multiplied by A and B. Am I correct? M is the couple, yeah? So therefore, your F, which is for A and B, for example, is basically the moment that you calculated here divided by the A and B. Okay, you understand me or not? You understand me or not? So you have this one in Newton. So if you have a force A pointing upward and you have force B pointing downward, so that what this force called? You learn in dynamics or you learn in static, called as what? Compression, isn't it? Or tension. Compression or tension force acting on bearing A and B. Any question? Any question? We do not know, yeah, we do not know what will be the magnitude because there is no numerical at the moment. We are going to look for the principle first. Then you go for statics. Go for static. As usual, static must be constructing free body diagram. Dynamic is due to gyroscopic effects. Yeah. So if this is the statics and this is the thing, so this one is bearing, this one is bearing. So you have, if this one is B, this one is A, for example, you have RA, you have RB, and this one be your M. Mg. On static, you have two equations. On static, you have two equations. One equation is moment equal to 0 for the equilibrium position. The other one will be force also equal to 0. Both are for the equilibrium condition. So supposingly, I'm saying that this is what is M A, for example, is equal to, then you put it here, anything the rotating clockwise as positive, you will have this one mg divided by, mg divided, sorry. How come mg divided? It's not correct, yeah? It's not correct. This was mg multiplied by RA divided by 2, assuming that this one fall at center. Yes, this one fall at center. Center of the disc, for example, or midspan. Center of the shaft here, midspan. Then you have minus by, this one is RB multiplied by AB. Correct? Then use another equation, this one, saying that positive equal to 0. So you will have RA plus RB equal to MG. Then you know this one, what will be the RA, what will be RB. Supposingly, I need to use a numerical, otherwise I can't tell. So now, supposingly, let RA equal to RB equal to 100 Newton. Don't tell me where do I get this one. Doesn't matter. Just to put the numbers here. So you will have this one 100 Newton, this one also 100 Newton. So it simply means that this one is pointing upward, this one also pointing upward. But this one, remember, this one is on shaft. What is our aim just now? Is to look at the bearing. So therefore, you will have on bearing, we have RA is equal to 100 Newton, now pointing downward. Remember, this one because why? Because you are applying Newton's law. This one pointing downwards.
Doctor, in moment equation, the RA should be AB, right?
Sorry?
In moment equation.
Uh-huh.
The RA must be AB, right? MG
Uh,
times
No, this
MG
equation is correct. This equation is correct. This one is not. This one is, I assume. Okay, so that's why I put
why
let.
MG multiplied by RA?
Sorry?
Why MG multiplied by RA?
RA plus RB equal to MG, correct? Then what is your problem?
No. In the moment equation, why MG multiplied by RA?
RA, yes, MG, this one is half.
Yeah,
RB, okay, correct. This one, it's not correct. It's not correct. This one is not. It's not RA, yeah. It's supposed to be what? AB divided by 2. AB divided by 2. I put it AB divided by 2. It's not RB, yeah? AB divided by 2. This one is AB divided by 2. Okay? Is okay now?
Yes, doctor.
Okay, now. So this one is only numbers. I pick up any numbers, randomly. So because I want to show you this one, very important. And on the other hand, I also pick up another numbers, which I say that, okay, let's say FA equal to FB equal to 50 Newton. This one I just pick up in the numbers, yeah. So now you have this one. Look at the FA pointing upward, FB pointing outward. So you will have FA equal to 50 Newton pointing upwards. You have FB equal to 50 Newton pointing downward. The number is not important. This one important. What I'm trying to say, this one, because I am going to look for the resultant. Now is this time to look for this one. Let me open another file. 1 minute, class. 1 minute. Okay. Astaghfirullahaladzim. Okay. This one. Never mind. I just put it. Use this one. Astaghfirullahaladzim. Let me do this place. Okay. This one, yeah. Okay. Now I'm going to put together on this one resultant. What is the resultant? Is basically summation of F resultant equal to FA plus RE. This one for B resultant, but FB plus RB for B. This one is bearing. Okay, so I'm going to construct here. Okay, this is my just now. This is my shaft. This one is the bearing. The bearing. So you go back here. what you have? You have what you have? You have RA and RB are pointing upward. For shaft, bearing is pointing downward, so RA and RB is pointing downward. So this one is pointing downward. Use another color. RA, RB, 100 Newton. This one also RA and okay, look at the dynamics. Dynamic is what does dynamic just now? A pointing upward and the B pointing downward. Okay, A pointing upward, A pointing upward. Put another color, put it in the green here. A pointing upward, FA, 100 Newton. This one pointing downward, FB. So now the resultant, if you go back here, you have summation of FA, for example, summation of F resultant for A is equal to what they have just now, FA plus RA equal to, you put it numbers here, put the numbers, Astaghfirullahaladzim. A bit more, yeah, FA equal to RA is equal to, and saying that your bond equation say that anything that pointing outward as positive, I'm saying that this one is FA is 100, this one is minus by RB also just 100 there. No, I got mistake here. 50, astaghfirullahaladzim, 50, yeah. Sorry class, this one is 50, 50, this one is 50 Newton, 50 Newton. So you have this one is minus by 50 by 100. This one is 50 minus by 100. You get here negative 50 Newton. Correct. You do another time, pointing upward positive. Summation of F, but now F resultant for B is equal to FB plus RB is equal to FB is, where do you, FB is pointing downward. We have negative, is it 50 plus negative 100, you will have this one negative 150 Newton. And you can put it as a 50 Newton pointing downward. You can put it this one 150 Newton pointing downward. Am I correct or not? Yes or no? So now is the validation equation. The motion I will skip, because I have got 3 more minutes here. Validation. Any question up to here, class? Hello?
Doctor,
Yes.
for the force on the shaft, not one acting upward and another one acting downward.
Which one? For the bearing, this one is pointing upward, correct? This one is pointing downward, correct? Okay? This one is couple, remember? What is couple? Couple, 2 forces, one acting opposite direction, correct or not? Because it will create you clockwise. Am I correct or not?
Oh, okay, thank you, Doctor.
Okay? Okay or not?
Okay, Doctor.
Okay, now. So now, this is the validation question. So now, which bearing, number 1, which bearing has tendency to fail first? Number 2, what is the maximum force on the bearing? Number 3, in designing the bearing, which force is to be concerned or to be considered? This is a very typical question in exam. We call it this one as CTPS. CTPS, critical thinking problem solving. In the exam, typically in exam, not in test. The critical thinking problem solving, you have a number. So what happens to numbers? How you're going to evaluate the numbers? Now, listen up very careful, this one. So first, which bearing has tendency? This one has tendency to fail first. Bearing A or B? Hurry up, class. We are running out of time. Bearing A or B? A 50, B 150. So which one will fail first? Anyone?
B.
If you don't want to answer this one, I leave it like that. You have to answer on your own. Eva, A will fail first. Why A fail first? A fail first, correct. Why? Why? Yes, Eva. A is maximum, correct. So why? What do you call? We call in design. What do you write? What do I write then? It's a limitation. So A can limit only 50 Newton. 51 is start to fails. Whereas the B now can still running. So that is the maximum. So what is the maximum force? Is A is the maximum force. Understand that? This one is negative. This one is not talking about the integers. Negative just to tell you the direction where the pointing outward, the pointing inward. This is not integers. If we're talking about integers, this one is very small compared to this one. But this is not integers. This one talking about direction because we are dealing with vectors. Okay. On the other hand, the last one in designing the bearing, which bearing has tendency to in designing the bearing, which force is to be considered? If you want to design the bearing, which force? 150 Newton or 50 Newton? Yes, anyone? You want to answer this one? I leave it like that. Any question? Yes, anyone? Any answer? 150, 150. Yes, correct. This is the one. This is the ultimate force. Okay, yeah. Okay, 1 minute. 1 minute. 1 minute. I'm sorry. 1 minute. Yeah. So control. This one motion. Last one motion. We have this one. Okay, you have what do you have just now? The M. This one is M reactive. Am I correct or not? This one bearing, this one bearing A, bearing B. So you are saying just now A has a tendency to fail first. Am I correct? So A now fail first. So what happened now? If A fail first, this one fail. What happened? This one fail. What happened, class? What happened? The whole structure will fly this way, isn't it? Will fly this way. Correct or not? Yes or no?
Yes, doctor.
Yes,
Will
doctor.
fly this way due to the reactive. So if you are engineer, for example, yeah, if you're engineer, if you build a control room here, it's very dangerous, right? You cannot build this one. You have to build in front of this one because it will what? It will make a security to the personnel. Otherwise, if this one fail, it will hit your control panel or operator, whatever it is. So this is the motion or the what do you call it, the possibility of talking about the engineer when you design something. It is not up to the force. You have also to think about where will be the possibility to build a control room, operator where to sit, operator to where the workplace, so on and so forth. I'm sorry I got to run very quick because we are running out of time. I also got another class at 10. So any question, class? So tomorrow morning I'm going to continue. If most of you not attending, I'm going to explain a bit, but very fast one. If you are still join the class, so you'll be beneficial to you because it will be more knowledge if you attend so many class. Okay. With that, I'm sorry if I quite in hurry. So I'm sorry attending the class if you are not feeling very comfortable. So seeing again inshallah in the lecture. So with that, I end my session with Assalamualaikum warahmatullahi wabarakatuh. Wish you happy, stay at home, Stay safe and so healthy. Make sure you study to get good results in your test one and also in exam in all subjects. Thank you, class. So see you again tomorrow morning. Thank you, class.